So last practice problem, right? So function f, my domain restriction is that x cannot be 3, right? X can be all real numbers except 3. My domain restriction for function g is the fact that x has to strictly be greater than or equal to 0. So how does that work, right? So here we have function f of g of x. So we are bringing in, function g is bringing in its domain restriction of x greater than or equal to 0, right? So let's see, is that the only case, or do we have to bring in something else, right? So now we're going to figure out, okay, what is the composite function? So we have f as the bigger function, so we have 1 over, and again, wherever I see x, I'm going to put parentheses to remind me that I'm supposed to replace that x with the function g of x, which in this case is the square root of x, right? So now we kind of have this situation going on where we have a fraction, and we know that we already have this restriction on the domain, but now we have this new restriction where the bottom cannot be 0. And so that's what we're going to focus on to figure out what is my next domain restriction, right? And so we have root x minus 3. We're going to figure out when is it equal to 0 so we can avoid those numbers, right? And so we're going to solve for x by adding 3 and then squaring both sides, and that gives me x equals 9, right? So what that is saying is that technically my other domain restriction is x cannot be 9, right? So now how do we write this? Well, first of all, we're going to clean up our composite function by just getting rid of the parentheses. So that's my composite function. My domain restrictions now is we have to satisfy these two conditions, right? So x has to strictly be greater than or equal to 0, and it cannot be 9. And so how do we do that, right? Well, if we strictly have to be greater than or equal to 0, then we can be 0, because if we're 0 inside the square root, that's okay. And then 0 minus 3 is not 0. So we're okay there. So we're going to go from 0 to 9. Now we cannot be 9, because if we're 9, then the denominator is equal to 0, right? Union, and we're going to start from 9 all the way to positive infinity, right? So how do we know whether we did that correctly? Well, we can always graph it. So we head over to Desmos and we type our two functions, which was function f of x is 1 over x minus 3. And then function g of x is root x, right? And so we said my composite function has a new restriction of 0 included all the way to infinity, but we can't be 9, right? And so if we go ahead and graph our composite function, well, we start at 0, and it is defined, right? Because we have a point 0, comma, negative 0.33, which is negative 1/3, right? Where if you plug in 0, right, that's exactly what we get. Now, the other point was we said it can't be 9, so we scoot over. Now we kind of see our graph doing this, right? So I'm going to help us out. We have this line at 9, and if you notice, no matter how far we zoom out, now obviously for our purposes, kind of hard to see, right? But if I do this, make it a little bit prettier, well, you get the point, right? So you can see that 9, it's not defined, right? It goes to positive infinity, negative infinity. And so that confirms that our domain restrictions were correct. And so then we have my composite function g of f of x. So function f brings its domain restriction, which is saying x cannot be 3. And so then we go to our bigger function, which is the square root, and then x is the only thing inside my square root function, so I'm going to leave it blank, and I'm going to replace x with function f, which is 1 over x minus 3. So now we have to create this new domain restriction along with this, right? So we have a square root, so that stuff inside has to strictly be greater than or equal to 0. But if this is 0, since there's only one x value and that's in the denominator, then we can't really be 0, right? So 1, we have to be strictly greater than 0. And so that's kind of what we're looking for. So we're going to focus on this, right? So the fact that this top number, right, it's a 1, it's not changing, right? It's always positive. So then that means we only got to focus on this, right? So we got to figure out, when is x minus 3 greater than 0, right? Well, 1, we already know that we cannot be 3, so we strictly got to figure out, okay, well, when is it greater than 0? And we simply add 1, and so it's going to be greater than 0 for whenever x is greater than 3. So then my restriction, right, so g of f of x, so my composite function is 1 over x minus 3. My domain restriction has to satisfy both of these two things, right? It has to satisfy this, which is the domain restriction that I came with, and my new domain restriction that I came up with. Well, if it's not equal to 3 and it had to strictly be greater than 3, that's already satisfying both, right? So here my domain restriction is x has to strictly be greater than 3, right? So how do we write it? Officially, x greater than 3. X can be any number, because as long as it's greater than 3, then we're good. And again, how do we check? Well, we can always graph it, right? And so here's my graph, and if you notice, we have a vertical asymptote at 3, which means that it's not defined there, and my function is defining everything to the right of 3. And so that confirms that our answer, or our domain restrictions, were correct.